Okay. Again, I have a timer, so if I ever pause awkwardly, I'm writing timestamps for the YouTube video. Okay, so just to let everybody know on that. Do 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 do. So yeah, Lily, what are you thinking? Because you have a totally different study guide too. So whatever you need. She's in Nenya's class. I'm really happy you came. Very much appreciate you coming. Oh, you're fine. Would you prefer if you went like second? Did you want to? Would that be better for you? Sure. All right. What do you guys want to talk about? Okay, that's closed. I closed that file. Lame. Let's open up the file. Okay, good. Okay, where are all my reactions? All my reactions at? Where are all my reactions at? Where are all my reactions at? All my reactions at? Yeah, whatever you want. It's whatever you say. I've already gone over some things in like every video, so I don't mind. We'll keep going. The one thing I say we don't need to do any more of is Le Chatelier. Lily, we can if you ask, but I don't think from everybody else we've done that with them so much. You know, I don't know if it's worth it anymore. Because I'm not trying to confuse you on one topic of the final exam. You can all do well and bomb one topic, you know? It's not that serious. It's about all the topics. Molarity and dilution, done. Excellent. I'm sharing my screen this time. You guys catch that? I'm improving. Okay. So, this is molarity. This is dilution. Okay. So what these both come down to is these are solution questions. Okay, so this was on the 4A test, the first part of Unit 4, or test number 6. I think Lily, he calls it that. I think he doesn't call it like the units like I do. So essentially what molarity is and what this equation is trying to do. You see N is moles. So moles, okay, moles is the amount. That's all moles is. Okay. So right now the school doesn't have a large mole of students. At Catspies, there were more moles of students. During the school day, there's even more moles of students. So it's all about amount. And then, as you guys know, it's going to be divided by liters. It does have to be liters. It cannot be milliliters. Okay, it has to be liters. And this is going to tell you how strong a solution is. Sorry, I forgot I didn't do a timestamp. My fault. My bad on that. And by strong, I mean how the higher the concentration is, the more that chemical is present. So, for example, like something like not spicy, right, might be like 0.05 molar, but something very spicy, molarity might equal 10. You know, something like that. So the bigger the number is, the stronger it is, which means there's more stuff in there. The bigger the top number is, the bigger the molarity is, and vice versa. The more water you have, the liters, because it's a solution, right? Aqueous. the least it's going to be. You guys know if you want something like to be like weakened, add a liquid to it, add more solid to it, make it weaker. That's the liter part. So essentially, if you ever had that really wimpy like summer lemonade kid, like that elementary school kid who's trying to make like a quarter a lemonade cup, it's really watered down. There's a lot of liquid, but there's no sugar or no lemon in it. It's going to be very weak, a very low number. And then dilution is literally what I just was mentioning. It's water adding water or taking water away. So when you're cooking, right, if you're making soups and stocks and things, they're reduced. So everybody at every home kitchen that cooks seriously, everybody who's at a restaurant, they're reducing these sauces. For example, like a mole, right, or reducing and thickening down like a salsa to get those flavors out. If you want it to be weaker, you add water. So essentially, if you water down and reduce it, we could figure out how strong it is. So the first volume, if the volume goes up, the molarity goes down. So these are just like Boyle's law, inversely related. The more water, the weaker it is. Which you all know that already. That's not too crazy, right? And that's kind of the premise before we do a few equations. Okay, any questions so far? That's kind of just the premise. This is about a solution. This is about the amount of solid you're putting in, and this is how much liquid you're putting it into. This is, are we adding liquid or taking it away? Are we okay so far? Not too bad? And then we'll do some math problems. He. Okay, she. I don't know. I don't discriminate. Okay, my students, we good? Okay, that's 1 ya, 2 ya, 3 ya. Okay, sweet. Okay, cool. Let's do a problem. So we're going to go at 7:30. Okay. All right, let's make up a problem. We'll do an easy one and then we'll do a harder one, okay? We're going to start. Ooh, here's what we'll do. I'm smart. We're going to go boom, 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 boom. Okay, cool. So the one thing I wanted you to notice, one, these are on the final. You don't need to memorize these equations. All the equations are on the final. You can use Mole Island, all those things. So if you have 9 moles of salt and 300 milliliters of water, what is the concentration? So this is the problem. Concentration is again molarity. So no big there. So which equation are we going to use? Are we going to use equation 1 or are we going to use equation 2? Okay, I got one person saying 1. I got 2 people saying 1. I got 3 by P. Okay, good. That is correct. Very good. And the way you can tell which is which, this one has 2 molarities or 2 volumes. So if you see 2 volumes or 2 molarities, it's this one. This one, it says moles and it says 1 volume. And you have no M yet. So this is telling you it definitely is number 1. So molarity equals, we have 9 at the top. We have, okay, 300 at the bottom. What's wrong? I did something wrong. Correct. Correct. This is bad. We cannot do this. So the way you go from milliliters to liters, you just divide by 1,000. So 1, 2, 3. I know it's been a while since we've done that. It's 0.3. So 9 divided by 0.3. Oh, this is going to be a big number. Yup. This is going to end up being 30 molar. This is stupid strong, unsafe levels of power. And that's your answer. Done. Cool. That's not bad, right? Are we okay so far? Okay, let's do a harder one. Okay, we're gonna do a harder one. We're gonna use this equation again. So actually, I'm gonna delete this one. If you have 1.25 molar of a solution that is 2.25 liters, how many grams would you need of Li2S to make that? Uh-oh. I said grams. Is this grams? Yes or no? Is this grams? No. So we have a problem. 1. Mole Island. We need to connect moles to grams. We know how to do that. Okay. So we are going to need to use these islands at the end. But we, again, just to remind you, just from the jump, we have a way of doing this. Also, this is one of my favorite drawings. I did like the Teletubby Wizards and Doc Hudson. So this is one of my favorite mole islands. So I just grabbed this one. But again, just so everybody is aware, we're going to use this at the end. So just to let you know. So we got to find moles first, though, because it doesn't say moles. So this is going to be 1.25 equals X divided by 2.25. What up, what up? We're doing a harder problem right now. Just to let you know. We're doing one with Mole Island, if you missed that. So it says grams. That's moles. Mole Island. Okay, we need a Mole Island part. So I'm going to be honest. There's multiple ways to solve this. Does anybody need me to solve X when it's like this? And if it helps you, I'm going to rewrite it maybe a little nicer. It would also maybe look like this, if that's a little easier to look at. Does anyone need me to solve this? Are we okay? Because the answer, okay, X is 2.8125 moles. Do I need to solve that? Be honest. There's nothing wrong with admitting it. That's what I'm here for. Do I need to explain how I got that? Okay. Yes, you can cross multiply. Yes. Yes, there's 2 ways to do it. One, you can cross multiply because there is an invisible 1 underneath. So you could totally cross multiply. So 2.25 times 1.25 is 2.8125. And then 1x is x. So that's easy. You can totally do that. The other way to do it, though, is to get x alone. If this is at the bottom, you got to multiply it to cancel out. So if you multiply both sides by 2.25, these cancel, and then you're left with 1.25 times 2.25 again. So either way, it's exactly what Yuritsa said. You got to multiply them together. Does that make sense, Genesis? And that's what you have to do. Now that we got the moles, we got Mole Island. That's nice. So I'm in moles. I need to go up up is multiplying by the molar mass. We can do that. We can definitely do that. So let's look up what chemical we have. We got Li2S. Okay, so lithium weighs 7, and there's 2 of them. S is 32, and there's only 1 of them. So 14 plus 32 is 46. And that's again going to be your grams per mole. And then, just like Mole Island said, going up is multiplying. Always going away is multiplying. Up, multiply, out, multiply, and going in is always divide. Divide by molar mass, divide by 22, divide by 6.022 times 10 to the 23rd. We've done this a bunch. So 2.8125 times 46 equals... And that's your answer. 100.4 grams. So not a lot, actually. So you would get 2.25 liters. You would take 100.4 grams, put it in the liquid, the water, stir it. Done. This is how we make solutions. This is how Mr. NIE makes the solutions for all the AP Chem labs. This is how I do all the solutions when it needs to be exact. This is what I'm doing. And that's about as hard as it gets. Do you feel a little better with that one? Oh, good. Okay, perfect. You beat me to it. And again, the other one, okay, it's weird. The other one with the dilutions, that one you're just solving for X as well. So we're gonna do one of those next. Any questions on this one though before we do a dilution? Okay, cool. So let's do another one. Let's do the other equation. Okay, this time we're going to do a dilution. So with the dilution, again, there's 2 volumes. So, and I'm going to just go jump to a hard one because this one, you just plug in the 3 numbers. So this one is pretty easy to solve for X, but I'm going to make the wording a little challenging. Okay, this was a hard one. This got a bunch of you on the test. If you have a 0.78 molar solution of whatever salt, and you start with 500 milliliters, if you add 900 milliliters, what is the new molarity? So I see 2 milliliters. I see 2 molarities, even though this one's X because we don't know it. Yeah, we're definitely going from here. So it's definitely this one. It's definitely this one. What up, best friend? So with this, let's plug it in. So we got 0.78. We've got 500. We've got, I don't know. And we've got 900. What did I do wrong? This is the mistake a bunch of you made on the test. This is very close. With this one, nope. Actually, thank you for mentioning that. Lily, thank you for mentioning that. With this equation, it doesn't say L, so it could be either. It could be milliliters or liters for this one. Okay, long as they're the same. So the fact that this both says ml, you're good. You don't have to convert. If you do, you'll get the same answer. Good, good comment. Yes, adding what? Nice job, Daniela. Multiplying is good because there's no plus sign here, but you're right. That's a mistake. So Daniela, you're good. It's just where is it? Good. Yeah, we're definitely going to multiply here. What is wrong with this? You're going to have to isolate X, yes. But that's not what's wrong. Something is wrong here. If you unmute yourself. Okay, good. I'm fine. Sure. Sure. Vacuum in the background. That's good. I'll allow it. They'd be savage if you were on the vacuum. Sounds like excuses. You're correct. Very good. It says add 900. It says add 900. It does not say 900. So this is wrong. What it should be. It should be that. A lot of you miss that on the test. You gotta make sure you're reading it. Because if you do that and you're a doctor, that medicine's wrong. You do that and you're trying to like synthesize something, you messed it up. You're trying to do a flavor for something in a food lab, you messed it up. You gotta make sure you're adding or subtracting the amounts if it says to. So let's solve this. So first off, this is going to equal 1400x. So let's see what the top one is. So again, a bunch of you said multiplying. You were correct. Very good. This is 390. And to isolate the x, Genesis, what do we have to do? Oh, how did you get 1400? It says add 900. So if I have 500 and I add 900 more, it's going to be 1400. Thank you for asking. Thank you for asking. Genesis, what do I do next? Oh, no. Correct. Oh, no. Danielle, you're oh, no. Oh, no. Oh, no, Danielle. That's not good for you. Leslie just emailed me that you're the next person I'm going to give all the food to for the meats. She said she wants you to be the next person. So congratulations. You're going to give a lot of food. Oh, no. So divide by 1400. Very good. Sorry, I typed 390. I wasn't expecting that email right now. So that cancels. So 390 divided by 1400 is 0.279 molar. And that is weaker, right? We added water. So it started at 0.78. It's now 0.28, essentially. This is way weaker. And it should be, right? We added a lot of water. It should be weaker. This makes sense. And that's the dilution. And that's really it with the math with those two equations. It's one of those, like, if I show you the grams, if you see grams out of nowhere, right? I don't blame you. If you're thinking molarity and you see grams, there's no grams here. And there's no grams here either. So admittedly, it makes sense that, if you need a little just to see it a few more times, where am I going with this? It says grams. But now you know Mole Island. Just a little reminder on that. You can do Mole Island. We all can do Mole Island. You guys are great at Mole Island. So don't be afraid that this is there. Look at this. Look at Doc Hudson. Look at the Wizard. Look at the Sharks. You're fine. Okay. And then this question, read it. Don't number hunt. Okay. Never number hunt. I know you guys do. I know you guys do. I can see your eyes. There are sometimes you're in a test. I can see what you're doing. If you're reading, your eyes should go like this. And I don't know how well it's showing on camera, so I apologize if this is a little weird. But I hope you can see that it's sliding. You guys, when you do some of the problems, I see this. You're not reading it, you know? So, Lily, when I do Mole Island, we draw it step by step to go over it. That's why we get through that unit so fast for the cookies. Because if we go through it, oh, Dee Dee! What up? That's why, that's really why I think we do so well in my class on it is when we draw it step by step, we literally go over every single little part, every arrow, every color. Why are these three things here? We go over everything. I make them tell me these three islands. I don't teach them these three. They tell me. So that helps. I think this is my best lesson of the year. And people did good. But yeah, any questions on the two equations? That covers all of it. That covers everything completely with those two. And we reviewed solutions, so that's good. So yeah, so Danielle and Dee Dee, we just went over the two math problems and what the equations mean. So we did three practice problems, and we reviewed. Are there any questions? Are we okay with that? That's a great start. We have not talked about that yet. That was good. All right. If there's no questions, because I'm just waiting for a delay, maybe. What's next? What do you guys want to talk about next? No questions. It's only 9:09. Oh, final exam is 90 questions, 9 math. Lily, that's what he said, right? Yeah, 90. Yeah, it's 1 per minute. Yeah. I said that in class. Very similar. There's a few. Lily, I want to be honest with you. There's a few differences. I'm not going to tell you how many differences, but there's differences. Just little ones, but they are different. But it's the same concepts. Oh, acid base? Yeah, I saw acid base. Yes, let's do acid base. Because we have not done that yet. Yes, good job. Okay. Yes, let's go over acid base. Because that's the third type of reaction. That's going to be a big thing. Oh, Also, all the math equations are given to you. I'm going to give my students a sheet of paper with all of them in order. So you could do the math first and just finish it and then just plug it in. And also, too, it's multiple choice. You know what I mean? So if you know 7 of the math problems, 5 of the math problems, right? 5 to 7 is good. You know, if you can get a 5 to 7 on a 9, that's good on the math part of a final. Can you get 7, 8, 9? So even if you're guessing on 1 or 2 of them, or you're like, okay, heck with the 3-step, read the answers. Some of them might not make sense. You know what I mean? Get rid of them. So acid base. Okay. Acid base reactions. Fantastic. Acids start with H. Bases end with OH. As we talked about before, with precipitation, when you're putting these chemicals together, okay, this works for precipitation as well, but this is the same setup. You need to be aware that positives always go first. So when you're putting these together, it needs to be the outsides together, which is AD. And you need to put the insides together, obviously, because that's the only combinations you can do. You cannot put A and C together. They're both positive. They will never touch. They will repel. And that's CB. Again, I've been saying this in my class the whole time. All dogs can bark. And I think next year I need to play like a 20-minute video of dogs barking and just have everyone stare at it. That'd be funny. All dogs can bark. Puppies. Just have puppies on the screen. Just have cute puppies barking on the screen for like 10 minutes. And just sit there and just make everyone watch it. Don't say a word about it. Just puppies. Next year's gonna be so much more fun than this year. I'm gonna go crazy. You guys are gonna come back and get mad at me. Anything but chemistry. Oh, I want to make you jealous. I want to make you jelly like a felly. Bye, Lily. Thanks for coming. But you know what? Last year's group would say the same thing about you guys. So every year you always try to make adjustments, right? You try to be better. You guys really helped me figure out block. So I promise you this. If I ever do the ice cream lab, you guys are invited. All of you. So we'll go from there. So going back with the colors, HOH is water. You. So acid-base reactions always make water. Water is clear. Water is a liquid. Something to keep in mind here. Okay, water is a clear liquid. And the other thing is we need to put these two things together. Let's just call it X and Y because it could be anything. Again, Y would have to be first. This is a salt, always. This is always a salt. Always a salt. And salts are aqueous. So, long story short, a acid-base reaction always makes a salt and water. So that's why this is a little different than your usual reaction. Again, just to make sure I'm clear. That's why we need an indicator. So you need an indicator to see the reaction changing. And this makes sense. You saw those color changes with all those indicators. Yep, salt is all aqueous. All salts are aqueous. Every salt. And that's not just table salt. Table salt is one type of salt, all the salts. So in my like healthy drink I always have in here, there's other salts in here, not salt. Like there's, potassium chloride for electrolytes, that's a salt. Always. The beet has a lot of electrolytes. Yes. The beet is in here. It's actually really strong in here. This is like spicy beet. But those are other salts as well. It's not just table salt. It's every salt. Essentially, go look at a food label. All the chlorides, all the bicarbonates, all the sulfates, all the nitrates you see, just different ones, those are all salts. They're for preservatives, for flavor, like MSG is a flavor, monosodium glutamate. That's a salt compound. Salt's a very big area of compounds. Pretty much anything ionic that dissolves. That's a lot of stuff. Yeah, what you making fun of? Yeah, whoa, 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 whoa. Yeah, don't make fun of her. It's 2-on-1. You're not going to win that. Especially when I'm coaching you over the summer. You're going to don't do that. Oh, you're not hating? Then we're good. We're good. We're good. Are we good so far? This is the basics of acid base. Acid is H, base is OH. They make water and salt, so you need to have a color change. Oh, I should add color change. Lame. Boop. There you go. Good. Are we okay? The indicator is going to be a separate compound. That you know how so when you mix the chemical that changed color, like nothing really happened. It just changed color. The indicator is going to be like a third chemical here. So if you remember the Will It React lab, like the biggest failure of the year, it was up here. So you don't need to worry about that in the equation. Yep. XY is the salt. Yep. Always. Yep. And honestly, too, again, for the test, I'm not going to like make you know that. What you need to know, it makes water and salt, acids are H, bases are OH. You need a color change. No color change, nothing happened. And you know that. You know what I mean? Like, if I take my juice out, it's going to be dark red. If I add salt, it's going to stay dark red. Nothing happened. It just mixed. You know what I mean? We okay? Am I good to go to the next part? Okay. So if you don't mind, I'm going to get a scale really quickly. Acid, base, pH scale. Because I want to talk about strong versus weak. And again, this was in a tutorial you guys did. From what I heard, I think that acid base tutorial might have been the best all year, just based on like what you guys were telling me. So that's kind of cool because I didn't do that one last year, so that's fun. So I appreciate that feedback. So the pH scale, it's kind of let me make it big. The pH scale kind of goes like this. So you got your 1 is an acid, 14 is a base, 7 is neutral, which is water. So water is this. If you see alkaline water, okay, at the store, it's a big buzzword. You go to the water section, it'll say alkali water, alkaline, alkaline water, any of these words. Alkaline means base. They're not basic. If there are there are basic waters, that are over here at 5. You could test it. You could almost taste it in some of the waters. So don't believe any of that basic stuff. It's just a way for them to charge more money. I'm not lying. That's how it works. Okay. So if you ever see alkaline water, don't waste your money. Okay. Don't waste your money. The reason I'm mentioning this, okay, is these are strong acids. Okay. These are weak acids, kind of over here. Then you have weak bases, kind of like over here, 9, 10-ish. And then you have the strong bases, which are over here at 13 and 14. Okay. This, I think they have good examples. Like stomach acid is really high, lemon juice, apple juice. Any soap or cleaner is a base. So those are going to be over here, bleach. Your eggs and dairy are over here. Your meat's over here. You could live like your veggies are over here. These are like spinach, lettuce are over here. Broccoli's over here. Kale's over here. Anything of coffee's over here. Anything earthy tasting, bitter is over here. Really, really, really dark chocolate over here. These are your citric things, like your fruits with citric acid, stuff like that. Matcha would be over here. Yes. I haven't had matcha in a while. Matcha's good. Matcha would be over here, I would predict. Let me look. Let me actually. My assumption would be 10-ish. 9. Not bad. Yeah, 9. So we were right. Yeah, anything more earthy is over there. It says 9. 8 to 9. Very good. Good. Hey, let's not talk about Joseph right now. Joseph could be pretty acidic. Joseph could, you know what I mean? Very good. So, with this, okay, the reason I want to mention this is what's the difference between strong and weak? I know you can see the numbers. That makes sense. But what is it? So a strong acid or base is all aqueous. Okay. A weak acid or base is not all aqueous. That's the difference. Okay. And you saw this in the simulation. And I'm going to switch over so I can do the new drawing. I'll go back if you guys need me to. So with the strong acid and base, it's going to be like all broken up. All broken up. Nothing is together. If it's weak, oh no, not my best moment. It's not going to be all broken. And even if it's just one little piece, or maybe it's a lot of pieces that aren't broken. This is in the simulation too, if you remember. It was gray. Either one of these, it's not all broken. Again, because of this, 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 and this. These are weak. So essentially, if everything is broken, that's aggressive. And that's really it. So if every chemical is breaking apart to be an acid or a base, that's going to be stronger, right? If every little particle is attacking you, yeah, that's strong. If not all the particles are attacking you, that is weaker. And that's how it is. And that is acid-base reactions. That's everything. So again, acids are H, bases are OH. They make water and salt. This you can't see the color of, or you can't see a reaction because that's clear and that's dissolved. So you won't see if these are working or not. You need to add a indicator to see the color change that tells you which one's winning. You put them together just like you do a precipitation. That's a great thing to review. Low numbers are very strong acids. High numbers are very strong base. In between, they're kind of weaker. And the difference between strong and weak is that's aqueous, that's not. And that's it. That's everything you need to know about acid base, which is the third reaction we didn't go over yet, which is wonderful. Are we okay? Any questions? Genesis, are we good? Alma, are we good? The rest are we good? I'm goof. Oh no. Oh no. I'm goof too. Don't worry about it. Okay, good. DD Daniela, you're good? Awesome. So yeah, that's everything with acid base. If we're good, what would you like to talk about next? That was the last main topic. So I was happy with that. Because again, the final's a lot of vocab. You know that. Like it's a final. Like there's only 10% is math. Like it's going to be a lot of vocab. So this is wonderful that we went over this.
Is there gonna be like net ionic equations?
Yes.
Oh.
Would you like me to go over that?
Well, yes.
Which one do you want to do first? Precipitation or redox? We'll do both.
What the? Bro, we did not link mines. You copied me.
So
I think...
which one do you want to go first? Let's see if you're linked.
Okay. Precipitation.
Okay, let's do it. All right, I'm going to... Oh, and again, the only reason I'm going to do it like this, I have gone over a few in a lot of detail. I'm going to just pull that slide up and show you everything. So I'm going to show you how every step works because that'll, I think, save time. Is that okay?
Yeah, that's fine.
Okay, cool. And if not, we'll do more. We can do more. Okay, I'm just waiting for this to load, and then I'll switch screens because I have two good problems. Good. Okay. Oop. Don't share that. We do not want you seeing that. That would bore you. Okay, good. So first off, net ionic equation. We're going to start with precipitation. So 48, 40. Okay, sweet. So we're also going to go over precipitation reactions. Okay, very good. So with precipitation reactions, the whole point of it is you need a solid, period. If you do not have a solid, it does not work. Period. End of story, move on. Okay? Because if you mix water and salt water together, two different chemicals, water and salt water are different. If you mix them together, nothing happens. I dare you, go do it at your house right now. Get a glass, get another glass, put both with water, add salt to one, mix them. Nothing happens. Nothing. Because everything is aqueous. So how do we do this? So here's your full equation. Okay. The way I got this equation, again, is the inside-outside thing we just talked about. So Mn will go with CO. Actually, let me show you. The Mn is going to go with the CO3. That happened. And the NH4 and the Cl is going to be over there as well. So Everything checks out. All dogs can bark. So what I did was I looked at my solubility rules. Again, you are allowed to use these on the test. So just as a reminder, they are right here. You may use these. Not a problem at all. I have extras if you need. So this is aqueous rule 4. This is aqueous rule 1. This is solid rule 5. And this is aqueous rule 1 as well. So we have our solid. We're good to go. Are we okay so far? First thing we got to do we have a solid? We do. We're good. I need to see something happening. That something you see is the solid. If it doesn't mix, nothing happens. We okay? Are we okay? Okay, 1. I'll see at least 2 more. Okay, we're good. Sweet. Now, aqueous means dissolved. So aqueous means that it's going to pull apart. Okay? That's what aqueous means. So if it's dissolving, like salt, it's going to split. So this is aqueous, it splits. This is aqueous, it splits. Okay, please notice I put that 2 by the NH4. I put that 2 in the front just to help us out. Okay? This is a solid. It does not break. It's a solid. Do not break it. This is aqueous. Break it. Again, you'll notice I put the 2 NH4 over here. Then we did everything we needed to do, and we're literally just canceling things out. So net ionic means we're going to reduce the equations. Net in math and science means you're going to reduce it. I'm trying to get it to be as simple as possible. Even though we have all these chemicals, what's actually happening? Not all the extra fluff. What's happening? So you'll notice I canceled out the 2 NH4s. Same before and after, nothing happened. The CLs, same on both sides. I got rid of them. And Danielle and Didi, you'll notice I literally just rewrote the rest. And that's it.
So you just basically like cancel out the stuff that's like the same?
Yeah.
Bruh. Okay.
But the first step you got to do is you got to look up this so you know what to break. This part right here, and again, I'm going to get rid of this mark because I'm going to make a mess. On the test, because a lot of people didn't do that homework. A lot of people skipped this step completely. A lot of people literally skipped this. They tried to go from here to here. Some did. I'm not going to lie. Some did. But most people made a mistake or mistakes. So this is optional. I'm not going to lie. This is not what I'm asking you. I'm just asking you to reduce it. This middle step helps a lot of people. So I highly suggest to do it. Also, admittedly, that net ionic homework was the least turned in homework of the year. So it does make sense why, sadly, that didn't go well. That's why I'm redoing the Will It React lab. The Will It React lab, on those 11 yeses, you will have to do the net ionic next year. So you don't have to do it, but you guys don't have to worry about that.
I still did it.
Well, I appreciate that. Because very few did. And that helped you. Because you did way better on that retake, so that was good. But are we good to see another one? Let's see another one. So this one, same thing. That's aqueous rule 1. That's aqueous rule 1. That's a solid. Again, please note, it's not always going to be the third thing. It could totally flip. Right? We're allowed to flip. Right? We're allowed to flip. We're allowed to flip. So we're going to break everything that's not solid. We broke this. Again, I put that 2 over here. 2 Ks, 2 Fs. This is a solid, so I just rewrote it. It doesn't dissolve. Like this doesn't dissolve. This pen doesn't dissolve in water. The ink does, but not the pen. And then the 2KNO3, I broke that too. And then, yeah, the two NO3s cancel. The 2Ks cancel. And then, yeah, the SR's left, the 2Fs are left, and the SRF2's left. That's all you have to do for the precipitation ones. Again, if it's all aqueous, don't do it. If it's all aqueous, everything breaks, everything will cancel. Don't waste your time.
Bro, it's because, like, in theory, like, it actually does make sense, but then, like, once it gets to the test, I just, like, start overthinking stuff, and then I, like, forget to somehow do stuff, and that's how I get bad grades. That's how I got an 8 out of 20.
Yeah. Do you feel like you were looking at this at the beginning, or do you feel like you weren't even looking at it? Like, admittedly. Because this is the start.
I don't even know. I probably wasn't.
Fair enough. And again, then it makes sense, right? It's because then you're guessing. So again, please make sure to look at your cheat sheets, all your cheat sheets, right? I'm going to be real with you. Some of your classmates are not. Where'd it go? Yeah, some of your classmates are literally not going to look at Mole Island tomorrow. Why? I don't know. Because there are 1 and 2 step problems on the test. Get those right. Those will take you literally 15 seconds. I'm not going to put a crazy molar mass on the test. Why would I slow you down? Right? I'm not going to do that. So yeah, just make sure you're looking at your charts, and I think everything will be fine. It's really it's the big thing, you know? And it was worse when I used to give this as one cheat sheet when it wasn't 2 small pieces of paper. A lot of people like always looked at the top one. So if this was at the top, they looked at that only. I flipped it the one year I put this at the top, everyone looked at this. So scores have been better since I cut it in half. But yeah, just make sure you use your resources. But again, you're doing good now, and that's what matters. Yes, we can do Stoich. Yes. Are we good with precipitation and ionic? Are we good to go to redox? Well, that's pretty good. Yi? Okay. Almo, we okay? Any questions on that? Okay, we like that. All right, redox. Okay. Good. Still gonna blame Evelyn. So with redox, the most important thing to talk about again with redox is what is redox, right? Because precipitation, okay, make a solid. Not a big deal, right? With redox, though, it is important to realize, yes, you're going to see a solid being made, but it's a different cause. It's the electrons. Okay. So the biggest thing to remember is if you're gaining electrons, you're getting reduced. Grr. Leo goes grr. Lions go rar. Rar. Meow. Rar. Okay. Whatever I can do to make you remember that. So if you gain electrons, you're reduced. The charge is going to go down. That's weird. Gain down. I know that doesn't make sense. Lose electrons, oxidation. If you lose electrons, it goes up. Losing goes up. Again, doesn't make a lot of sense. Here is why. Okay? What ends up happening, if you have charges, let's say +2 for both, if you're gaining negatives, because electrons are negative, 2 plus -1 plus -1 plus -1 is -1. 2 to 1 to 0 to -1. So you can see it dropped. +2 to -1 is down. But if I do 2 minus -1 minus -1 minus -1, 2, 3, 4, 5. It went up. +2 to +5. So you got to know what redox is. You need to know gaining is reduction. You need to know losing is oxidation. You need to know it's about electrons. The secret is it's about electrons, which is why I'm going to literally, when I give the math pre-test next year to honors, I'm going to put multiple subtracting negative questions to see where people are at, because that's something you need to remember. That, or I need to say electrons are negative every single day. Something. I got to do something. But that's key. So first off, that's redox. Okay. The key, you have to have both. Okay. It is impossible for you to gain an electron and then someone else says, oh, yeah, you gained it because I gained it. That doesn't make a lot of sense. You gained it because they gave it to you, or they gained it because someone else gave it to them. That doesn't make sense. It's got to be the same. So in this case, let's say that we have a problem like this. And I'm going to check something. Good. So in this case, right, we did a full-blown problem. This reaction does work. Okay, copper is better than silver, so this does work. We do need to check. That's this part. Okay, we do need to check 100%, or else we're going to be in trouble with that. But elements are all zero. So copper has a charge of 0. Silver has a charge of 0. These other charges we looked up on the periodic table. +2, -1, +2, -1. Those are all in the periodic table. Okay, or given to you because of weird question marks. So I did the charges first. Any questions so far? Are we okay so far? I have an equation. It does work. Copper is an upgrade. And I know zeros for elements because they're stable. And I know the other charges from the periodic table. Is that okay? Okay. Okay, good. So what ended up happening here, okay? Again, this does skip to the answer. The biggest thing I like doing is this. These are the half reactions. Javier had a great question last night about, like, do we need to, or the first night, do we need to do this? Some people try not to do this, and they got in trouble. Okay, some people tried to skip right to here. Very hard to do because you need to check it. Okay, so I highly recommend, again, do this. So Cu is 0. Now it's +2. So I wrote 0 and the +2. Ag was +2. Arrow went to 0. So this one went up 2. This one went down 2. If it goes down, it's reduced. If you go up, it's Leo or oxidized. This is a tie. I gain 2, you lose 2, we're equal. And that's good. So all that we did was I canceled out the CLs because they didn't do anything, right? -1 to -1. And I wrote what's left. Cu plus Ag +2, arrow, Ag 0 plus Cu +2. So I made sure it worked. I did the charges. I double checked the amounts were equal. I know which is fair game on the test too. This tells you which is which. This is great. And then I just canceled the CL and rewrote it. And that's it. Any questions? Pardon me. Any questions? Okay. I got a few answers. 3 more. Oh, 2 more. Sorry, 2 more. 1 more. Okay. So what about a reaction that doesn't work? Okay, let me show you one that doesn't work. Because again, aqueous, if everything's aqueous, precipitations don't work, so doesn't work. What about this one? Well, let's look at this one. So this, first off, this top one, CO2, LiF, F2, 2LiCl. Here's our problem. Cl is not better than F. F is the best. Cl is not better than F. It's not an upgrade. So we don't worry about that one. So this one doesn't work. So you don't have to do this reaction. This one's done. You don't need to do it. Okay. What happens, however, if you do? Okay. Now, with this one, I'm going to have you look at it for a few seconds before I delete a few things. Okay. Then we're going to redo it. So I'm going to have you look at it first. This is the answer. I'm not going to delete the answer. Okay. I'm going to get rid of some stuff. Okay. We'll redo it. And we'll explain why we got what we got. So, first things we did, again, this is the answer. Okay. So, aluminum is 0 because it's an element. It's stable. If I can hand you aluminum metal, you're fine. Zinc is a +2, periodic table. Sulfate is -2, back of the periodic table. Arrow, zinc is a 0. I can literally hand you zinc and you're fine. It's stable. Aluminum is a +3, periodic table. Sulfate, back of your periodic table, -2 again. So I looked up all that. None of that needs to be memorized. The only thing you need to know, elements are stable. And you know that. You're being bombarded right now with elements. You're fine. Nothing's happening to you because it's stable. I need to cancel the SO4 because it is -2. So that doesn't work. So we don't need to worry about that. So we need to worry about the aluminum and the zinc. Aluminum is a 0 to a +3. I wrote that down. Zinc goes from +2 to 0. I wrote that down. And this is where we have a problem. This is going up 3, and this one's going down 2. Alma, is that equal? DD, because you answered me before. DD, how do you fix these? Because 2 and 3 don't play. Make it 6. These both do play with 6. Daniela, how do I get a 3 to be a 6?
×2.
Good. Daniela, how do I get a 2 to be a 6?
×3.
Correct. So what ends up happening is with the aluminum, you're going to multiply it all by 2. So 2. Oh, wait, we already had a 2. So little hint on that. Zinc's become a 3. Okay. And you can see that's what we rewrote. The 2 ALs, the 3 ZN plus 2s, we got rid of the SO4s. Arrow. This 3 ZN 0, I put it at the end. That's okay. And then the 2 ALs over here. So, again, really good information. This tells you that the aluminum was oxidized. This tells you that the zinc is reduced. which is great. Also, if you were to balance this at the beginning, if you literally were to balance this 2, 3, 3, 1, you would have saw the numbers already. So if you balance it first, you could also do this. It just misses which is which, and I will probably ask you for that at least once. And this is a hard one. If you feel good, that's it. Any questions? That's literally it with net ionic. You've seen hard ones, you've seen easy ones. But yeah, any questions? Yeah, that's literally it. That's nice. That covers everything. Did you just tell me what LOL means? When I've used LOL already in this chat? Oh no. I'll be right back. I have to tell my wife that. Ugh. My kids think I'm too old and don't know what LOL is. I know. I know. We were around when cell phones were invented. Okay, bye. I'm going to leave you now. I'm going back to my students. You don't need to spend time with me. Oh, guess not. Well, I was banished. Oh boy. Was that Mateo? Who's Mateo? Any questions? Yuritsa, Genesis, how are you doing? Okay, good. He's nonchalant. Sweet. Okay, what can we do now? I'm gonna go back to the OG file.
For percent composition, do we like do we have to like find the like it's like we have to find the mass of everything and then like the mass of the separate ones and then turn that into percentages?
Absolutely. Absolutely. So that is perfect. Hello, hello. I know. Oh, jeez. Oh no. I know it wasn't you. So let's take CH4. Okay, something a little easier. Oh shoot, other way. Shift. No. What is it? Yes. There we go. No. Oh, no. Yeah, okay. Okay, we're gonna stop there. I did good. So CH4, we have 12 plus 1 plus 1 plus 1 plus 1 for the molar mass. That's 16 grams per mole. Okay. If I want the percentage of carbon, oops. And again, Danielle, you are completely right. I'm going to do everything you said. So if I want to do the percent of carbon, that's going to be 12 divided by 16, which is 7. Oh, again, times 100 because it's a percent, 75%. And the percent H is going to be all those ones combined because it's all H. That's going to be 4 divided by 16 times 100 again because it's a percent, and that's 25%. This is 100%. So you are correct. And you do the same thing, even if it's bigger, you do the same thing for every element. So if you have like glucose, you would do the same thing. So the percent of carbon is 72 divided by 180 times 100. The percent of hydrogen is 12 divided by 180 times 100. And the percent of oxygen is, that should be 96. And then whatever those numbers are. That's correct, right? Oh, did I goof? No. Is that right? Yep, I'm good. So that's how you do it. And then this is just to solve it. It's 40%. This is 7%. So this better be 53%. It is. Very good. Danielle, makes sense. We good?
Yeah.
Perfect. There's a few of those on the test. There's like 2 questions, I think, on percent compound on the test. What else can I do?
What is equilibrium gonna look like on the final?
So the definition's on there. So you need to know that equilibrium, again, is constant. Okay. It is not. And I'm going to try to where is it? 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 It's not equal. Okay. So again, equilibrium is when it's the same. It's constant. Equilibrium is this. Or maybe sometimes it's like this. It's like this rarely, but it can be. It's not this. This is not equilibrium. Woohoo! Yeah, we were equal for a second there, but it keeps changing. So you want to see the same results over and over again. 25, 27, 23, 27, 23, 27, 23, all the way down. So that is equilibrium. And again, that is constant. The other things on the test with that are Le Chateliers, how you mess with that. Which again, to be honest with you, we've reviewed the most of these YouTube videos. I am worried that I'm going to be confusing people at this point. So I would prefer not to, because there's other resources with Le Chateliers, but Le Chateliers is definitely on the test. Which again is like this stuff. Or this one. Yeah, equilibrium can be tough. Because there's a lot of people who say the right thing for me, but then when I ask them which way it goes, they don't know. But again, people are improving with it. And that's good. Like there's multiple people who emailed me a lot today getting better at it. So I appreciate those people who were emailing me. That was good stuff. That was good. And it paid off. So that's good. Very, very good for those people. Hint. Yeah. Oh, you want to do a shot? Okay, we can do a shot. Let me grab a reaction though, okay? Let me grab a reaction. I have a bunch of reactions. Which one is a good one? Ooh. Alrighty. There you go. What the heck? Well, that was anticlimactic. I copied it. What the heck? Oh, there we go. Yeah, what the heck is that? All right, we have this very nice reaction. I'm gonna make it a little bigger for everybody. So that's pretty large, but it doesn't matter. Okay. One. Okay. So what happens if we add is it going to go forward or backwards?
My brother says it's gonna go backwards.
Your brother's wrong. Okay. So first and foremost, I love how you all said backwards. Backwards is the best answer you could say.
Wait, it's not gonna work because it's K2SO3, not K2SO4.
Correct.
Bruh.
So do you guys see how that's a 3 and that's a 4? Be careful. Yeah, just be careful. Okay. This one is neither. This one's a no change. Yeah, it was, but you just gotta be careful. I will say this though. If you add K2SO4, you were all right. That was very good. If I change it to be correct, you are all right. I added it. I got to get rid of it. Go the opposite way. Very good. That is correct. You all got that one. That was good. I'm not going to play a trick on you anymore. Okay, no more tricks. Again, catalysts are good things, so don't worry about catalysts. What about if we lose Lucio? Why not? What if we Lucio?
Forwards.
Okay. Okay. Got 3 going that way. Yep, good. Good. Correct. Lose it. You need more. It's over here. Point at it. Good. Good. Okay. So with this one, okay, you're going forward. Okay. We're going to use this problem. If we're going forward, what happens to the H2O? Does it go up or down? I am not pointing at it for this problem. Okay, down, down. Down, down, down. Also, good job to your brother, too, for saying backwards before. That was very good. I think she might have stepped away for a second. Hey, it was a good guess. It was a good guess. Danielle, what do you think with this one? If I'm pointing at CO, what happens to the water over here?
Well, if a reactant goes down, then that means that the product is gonna try to go up.
That is correct. And that is happening right now because you're pointing at the products.
So down.
You are correct.
Okay.
Very good. So, okay, good. So everyone's doing really well. Good. Good. Let's do heat. Let's talk about heat really quick. Genesis, do you want endo or exo? Okay, it's exo. Okay, so she wanted the heat over here. Okay, this is exo. Ugh. Okay, cool. Okay, so the heat's over there. We're gonna. Yuritsa, do you want to put it in oven or freezer?
Freezer?
Sure. Which way is it gonna go? So I just dumped this reaction in the freezer. Okay. Got one answer. So you're saying forward. Okay, fair enough. Okay, so Genesis, if that's going down, what happens? Okay, it's decreasing. So if it's decreasing, do we want more or less? So which way are we going? Forward. Good job, Yuritsa. You had it. You had it right away. A little bit. He does a little bit. So yeah, he works the same as anything else, right? When you lose something, you need more. So you need to point at it. So if you put this in a freezer, the heat drops. You need to go forward to fix it, get toward the heat. So he works the same as anything else. And freezers lower the heat. So that's a fancy way of saying lowering the heat. I don't know who Greg and Rowley are. I haven't read a single one of those books. Obviously, it came out before it came out before. Whoa! It came. Whoa! It came out. Whoa! It came out way too late for me. Yeah, yeah, but and I haven't watched the movies. When did this come out? 2007. I was in sixth grade when this came out. Yeah, so? Okay. Okay. Okay, timestamp 131. Diary of a Wimpy Kid. I don't know, I'm sorry. I was reading like other stuff. I'm sorry. I was reading other stuff. I was reading the I don't know, what's it called? Darkwing trilogy? Oh, Silverwing. I was reading the Silverwing trilogy. Hey, I read that. I read that about 10 years ago. I gave her a book. I gave her a chemistry book. No problem. I hope you yeah, just it gets a little sciencey. Just let me know if you need anything. I haven't read it in a while. I should. Yep. It talks about why Napoleon doomed his troops. It was chemistry. He lost because chemistry. Yeah, but I'm sure you didn't talk about that in AP Euro. Napoleon lost because of chemistry. Straight up. Straight up. There were other things, but one of the main reasons was because of chemistry. So I'll spoil it. I don't care. So as Napoleon was trying to invade these regions, right? One of the regions he tried to invade, right? Where and again, I might be a little wrong, but really the Russia area, right? Russia in the winter is stupid because of the temperatures. What happens is Napoleon, okay, this is going to sound crazy. His soldiers had tin buttons on their coats. Tin. SN, element 50. Tin looks like aluminum foil. It's all that. But what ended up happening is tin, when it gets really cold, becomes brittle. It becomes like chalk. So as it got colder and the tin essentially became chalk, it crumbled. So there were no buttons to keep the soldiers warm. So morale dropped. They got colder, hypothermia. Some died because of that. So they couldn't really use the coats to stay warm. Also, Napoleon's buttons. Napoleon had aluminum silverware. His silverware was aluminum. Napoleon's silverware was aluminum. His soldiers had real silverware, real silver. Because at the time, aluminum was more rare than silver. So Napoleon had the good stuff because of how rare it was. Oh, there's no one else has aluminum. Well, aluminum's the third most abundant element on the planet. They didn't know that yet. It's super easy to dig. It's everywhere. He didn't know. They didn't know. So because silver has such a low specific heat value, silver can heat up and get cold really fast. So if you're grabbing silverware, it's cold. So eating, you're grabbing cold metal while eating. Aluminum would have actually been warmer because it has a higher specific heat than silver. So the silver like literally got cold for a long, long, long time. So morale again drops because eating's even a pain. But yeah, that's why it happened. Yeah, obviously Russia's bad in the winter anyway. But to make it worse, it was chemistry. Which is fun. The reason we have New York, chemistry. The reason we have New York City is chemistry. Straight up. We would not own New York if it wasn't for chemistry. The Salem witch trials, chemistry. Pretty much. But I'm sorry for the digression. I used to have the magnet students do a project in the book. I don't know if I told you guys this. I might have Dee told you. But yeah, everyone picked a chapter, like groups of 2 would like read the 30 pages and come up with a presentation. And then they would give me questions. Those questions would be the quiz. If people did good on your questions, I gave you a few extra points. If people did bad on your questions, I took away some points. So it used to be like presentations we did at the end of the school year. It went really well for the 2 years we did it. Really good presentations. I think only a few people like didn't do them of both years. It went really well. And again, it was only 30. I gave them 2 weeks to work on it. It was like a 15-minute presentation. It wasn't bad. Yes, we could do Stoich. Yes, we could do Stoich. And a matter of fact, we're actually going to grab this equation. We're going to use this equation again because that's how we do. Oh, hold up. We got room? Yo, let's get it. Okay, cool. Love this. Okay. So, with Stoich. First off, I just want to go over Mole Island really quickly because I think it's a wonderful thing to just go over it one more time. So, with Mole Island, and again, those of you that decided to take AP Physics next year, AP Physics is going to start out with this kind of math. So if you can do this type of math, you are way ahead of everybody else in AP Physics. Okay, so you got to cancel the units out, all that stuff. Division's at the bottom, multipliers at the top. I'm here. I can help you with that at the beginning. Normally I'm very good with quarter 1 of AP Physics. Okay, so just let me know. So with this, again, if you're going away from Mole Island, you're going to multiply. And that should make sense. 1 mole versus 2 moles. 2 moles should weigh more. 2 moles should have more particles. 2 moles should take up more space. So that's why we're multiplying away. We're dividing going in. Again, I have Mole Islands if you need. You can use yours, of course, but I do have extra. Okay. The key, though, with Stoich, or the 3-step problems, okay? We need 2 different chemicals. Okay. You're right. So what chemical do you want to start with? 1, 2, 3, 4, 5, 6, or 7? Okay, sweet. Dee, what do you want to end on? We need a different one, though, so don't say K2SO4. Okay, we do that, we do that, we do that. Perfect. Okay, random. They're 2 different chemicals. So when you have 2 different chemicals, right, they have different molar masses, things change. So essentially what we've decided to do, we need to start from here, and we need to go to a second one. And you can see I color-coded it, green and yellow. We're always dividing. Then we cross, decimal ratio, and then we go from there. Also, because I want to make sure. Okay. Just to make sure we're good, I'm going to balance this really quickly. And I did cheat, just to let you know. I'm not going to try to hide that. Okay. So what we're going to do, we need to start at particles, volume, or mass. I'm going to choose this problem just for the sake of things. But again, we need to move through this. So I'm going to group this, copy it, do one of these. Excellent. Okay. So we're going to start with 2.4 times 10 to the 24th particles of K2SO4. And I want, Genesis, what do you want? Mass, particles, or volume? Cool. Okay. So, very good. So, first and foremost, we're going to start at particles. We're going to go to volume. So, again, you won't have 2 mole islands, but you can kind of pretend. It's going to go 1, 2, 3. So, let's do what we do. Okay, and there's our 3 steps. The first thing, 2.4 times 10 to the 24th. Okay, that's particles. Oh, whoa. Okay, this is always a 1, and we're ready to start. Okay, this is our given. This is where we're starting. Before we start the steps, are there any questions so far? Okay. Missing 1 person. Okay. So we're at particles, which means I need to go up. So I need to divide. And if I'm going up to moles from particles, I need the particle number, which is Avogadro's number. So that's going to be dividing by parentheses 6.022 times 10 to the 23rd particles. And that's for 1 mole. And again, you'll notice I'm making everything green because that is our original chemical. At the end, I want to go to volume. Well, going to volume, going away is multiplied by 22.4. So multiplying is at the top. So these are both going to be gold. And we're almost done with the problem. So all I did, that was Mole Island. That's all I used was Mole Island. Any questions so far? We're almost done too. Any questions so far? Okay. So this is the new part for 3-step. It's always this step. It's always 1, 2, 3. So it's always this one. Okay. You got to switch colors. And again, I have colored pencils. You have markers. I can do we can do this on the test. I don't mind. But we got to switch colors, right? We got to go from this chemical to this one. That's where the mole ratio comes in. So, this one's going to be 3 moles. This one's going to be 2 moles. And you are done. I need green to cancel. So I need green at the bottom, which is why the 2's at the bottom. And I need the gold to cancel here. So that's why I need gold at the top. If you flip the numbers, you're wrong. So where did I get the 3 and the 2 from? Where did I get the 3 and the 2 from?
The numbers.
Correct. And Genesis, you're correct as well. It's the coefficients. Danielle, that's what you meant, right? Just to make sure.
Yeah, they said it better than I did.
You still got it, though. I knew what you meant. Good. And yeah, so again, if it was this one, you'd use 1. If it was this one, you use 6. If it's this one, you use 6. So it could be 6 and 6. That's fair. Or 1 and 1. We could have done that. And yeah, then we just solve it. So multiply the top, divide by the bottom. So I'm literally not going to hit enter until the end. So the first one, okay, times 1 times 3 times 22.4. So I'm just multiplying it all at the top. Now I'm dividing by 1, divided by parentheses 6.022 times 10 to the 23rd. I know it got cut off, but I'm dividing. Divide by 2, divide by 1. I have not hit enter yet. You still see the 0. And then you hit enter. And the answer is 133.9 liters of NH42SO4. And there are going to be a few of those on the test. Not a lot. 1 or 2. And that's Stoich. That's how they all work. And this one's harder because you have to remember the parentheses for 6.022. So just watch that. The equation will be balanced for you on the final. The balancing questions are other ones. But the Stoich one, it's balanced. I don't see why not. People have gotten hundreds before. I'm curious. I'm really curious. Oh, on my soul? Oh, no. You can be nervous, but don't let it control you. Just do your best. You won't even remember anything about it in a week. You know what I mean? Chemist try. That's true. That's what my chemistry teacher always said. My first one. You're fine. You need sleep, Yuritsa. You have other finals, too. You have other finals tomorrow. Bruh. So, Yuritsa, you need to look at math then. You've been to a lot of these sessions. I think it's math time. Don't overthink chem. I want you to focus on math, too. Wave the flag of East Aurora. Oh, math and chemistry? That's rough. Oh, that's rough, yeah. Well, I mean, I did offer you guys to take the final on Monday. No one took me up on it, so that's my haha. Well, not the final. You can't retake the final, but there's other things. And that's legit. You can sleep. That's legit. Retake everything. So, sorry about that. What else can we work on? Can I retake? Yeah, absolutely. The one from yesterday? Yeah. Yeah, 3 people retook it. 1 did better, 1 tied, and 1 did way worse. So I don't know what happened. Literally, the gauntlet. Everything happened. Yuritsa, I want you to go and look at math a little bit before you go to bed. If you don't leave soon, I'm going to kick you out of the chat. You've done good work. It's time that you look at math too. Even if it's just a little bit, okay? Yes, I'm gonna remove you. I haven't kicked anyone out of a chat. No, but you got to look at math too. Because I don't know your math situation. I want to make sure you're doing good at math too. I'm just one class, you know? You have other classes. And you have other finals tomorrow after that too. Because I don't know how college how's college or career doing it? Oh, you have an A? Okay. What's the A though? If you don't mind saying the percent. Are you safe? Oh, resume? Good. I like that. What's the percent? Because your definition of fine and mine are probably different. What is, if you're comfortable? How about this? If you're not above a 93, you should be making sure you're okay. 93 and above is normally good. 93 and above, 94 and above, and 95 and above are how the math work with 50. Next year, though, it's going to be legit. Next year's going to be crazy. You get a 20 on a final, you get a 20. Okay, you have the resume too? Yeah, the resumes are, and plus that's good. It's good to have a resume. It's good. You'll be ahead for colleges, senior year. It'll be good. That's good. Very, very good. Yeah, that'll put you ahead. Is there anything else, or do we kind of run out of steam? Okay, so you're good. Okay, 95 is very good. Nice job. Ugh. Genesis, are you good? Any questions? And Genesis, I didn't forget our deal. So you're good if you can get it to me. Oh, back to Stoich? Yeah, absolutely. Here, take a photo of this one. And then let me know when to switch to the other one. I can show you the I could pull up the one from yesterday too. Oh, was it yesterday or was it hold up. Oh, I don't have that one pulled up. Let me pull that one up. Okay, I think you got the photo by now. I'm going to show you the other one too, because we made another one up too. Doo, doo, doo. Okay, come on, load, load, load. And then I think it should be loaded. Okay. The problem's very small. Let me know if I need to do anything about that. Because the equation's so small, okay? And then this is a molar mass one that we did. I did this. Wait, hold up. Hold. Oh. Okay, I know what happened. Pardon me on this one. This. Unlock. Okay, it's acting up. Yes. So, okay, how do I want to do this? There you go. There we go. Sorry about that. In this, I was trying to move this start over here. This is right. Use this. There we go. Does anyone else need anything? And I'm wearing out too, obviously. I've done a lot of these. I'm very tired. Yeah, get some rest. And You're gonna be fine, Genesis. Just do your best. And I do want to say, Genesis and Yuritsa, you've been here pretty much every time. So I just want to shout you guys out. Not only did you get a bunch of points, like I do appreciate you guys. These sessions have gone. These are some of the best sessions I've ever done for final exam reviews in the 8 years I've done this. So really enjoyed these 4 sessions. Like very proud of you guys. This has gone very well. Well done. All right, I'm going to stop the recording so it can start to upload because it took forever last night.